Alright, so I'm doing actually a robotics stream right now, and I'm just gonna give you guys a little update on the robot. Um, Today I decided to go ahead and buy the main brains of the robot, which will be located in the upper stomach slash chest, so like right in the center of the torso, like right here, toward the spine. Um, I decided to go with um, a mini ITX form factor. The standard size form factor for a motherboard is ATX. The medium sized, smaller one, which is getting very popular now, is called a micro ATX, which is about 9.6 inches by 9.6 inches. That was the one I was planning to go with, but I decided we'd go even better with the mini ITX. When I researched my options for a, a desktop motherboard, mini ITX was more or less not really used at the time. Um, but it's gotten a whole lot more popular since I researched it. It's growing in popularity very quickly. So uh, it's now got better support, better options. It's a lot cheaper, so it was very doable. So I went with the Mini ITX motherboard. Specifically, I went with the MSI MPG B560i Gaming Edge Wi-Fi Mini ITX LGA 1200 motherboard, and that was to go with an Intel Core i5 10400 2.9 gigahertz 6-core processor. This is a Generation 10 processor. It's really good with 6 cores, and it's very fast. It's a economic budget build type processor for a gaming PC. So this is a quality gaming PC level processor for a budget build at 165 bucks, and so it should be really good for a robot. Um, this will be handling the robot's AI, computer vision, um, processing his ability to speak, various things. Unless if I end up going with smaller computers that might specialize in taking care of certain aspects of that. So I might have a separate, even smaller computer that takes care of like producing speech or doing certain online research so that he can focus on um, other tasks with his main computer. But we need a main computer to start out with. If we want to outsource certain types of cognitive abilities of the robot to smaller specialized computers that just do that one task, we can do that. We might have a smaller um, computer whose only job is to handle the balance of the robot or motion planning or processing audio, for example, audio processing so that it can do voice recognition or something like that, which we want to have all custom. Um, so we might be subdividing tasks into smaller other computers, or we might be able to run it all on one computer. I don't know how capable we'll be. I haven't even created the software yet, but we're just trying to create a nice gaming PC level computer to start things off. I was planning to put off buying the main brains computer until as late as possible into the build, but I think that now is a good time, and I do want to know how it's going to fit and how that's going to affect the fitment of various other things. So it was time to pull the trigger. Plus, I had the money saved up finally. So Intel Core i5 10400 2.9 gigahertz. We got the Mini ITX motherboard to go with it, which has Wi-Fi, which is very important for the robot. Um, and then we got the G-Skill Ripjaws V-Series 32 GB DDR4 RAM for 140 bucks, and then we got the Western Digital Blue 1 terabyte solid state drive, which is the M2 style, and this is a real miniature drive. It comes on like a card, It's my first time buying such a drive. I'm used to buying either a hard drive with the spinning disc, which I've had for many years, and then the most recent drive I started using was a SSD drive that was SATA style, and so it was like maybe this big, and had the little cables that plug in it still. But this one plugs right into the motherboard with like this little slot system, and that was the type of motherboard I had. Now with this smaller motherboard it had this type of option. Now maybe all the motherboards had this option, I just didn't even know what it was and I just was ignoring it. But so my most recent motherboard, I'm not sure if it could have handled this, but this is a 1 terabyte drive. I wanted to go with something big because the robot's memories are going to be on here, as well as a large library of objects it is capable of identifying, plus all of its code base. Um, as it learns, it's going to be storing what it learns somewhere. I mean, this is its brain, basically, so it needs to have a lot of storage. 1 terabyte, I feel, is good. I could have gone for 2 terabytes, but we can always upgrade to a 2 terabyte drive in years to come. We don't need a lot of space to start out. That's going to be needed in bulk later on in the process. Plus, we might even store his memories on the cloud. He might access the cloud in order to do his thinking for a lot of stuff. Maybe just have stored on board memories and knowledge and things that he needs to access very quickly. And then he would offshore, so to speak, things that he doesn't need to access as often. But then there'd be a waiting time. And if he were offline, he'd be very limited in his capabilities if everything has to be in the cloud. So it is good to have stored on the robot itself a lot of his knowledge, his capabilities, things he needs to know about. So 1 terabyte I felt was a nice starting point. And next, okay, so this is the basic PC build. We didn't need to buy a case because we've already got the robot itself is the case. We're not buying a block case. We don't need it. This comes with a stock CPU cooler. We might have to build a custom liquid cooling that will tap into my robot's liquid cooling systems, which use the robot's artificial lungs combined with a liquid cooling reservoir. We might end up using that type of system, integrating it into cooling the processor, perhaps in the future. But at least for now, I'm just going to use the stock cooling fan because the robot's all open air right now. It doesn't have a silicone shielding or anything, so there's no need to worry about trying to create a liquid cooling application for its main brain's computer at this point. That can always be something we add later, and that could be a fun project for us. So the next thing I want to go through is the power supply. I had to go with a custom thing off of PCPartsPicker.com. It wasn't, what I needed was not on that website. So what I had to buy here is a, let's make sure it shows up on the screen. Okay, move it down a bit. Alright, I bought on eBay DC 12 volt input, 300 watt, high power, Pico DC, ATX 24 pin, mini ITX PSU. So this is a PSU that basically has 24 pins, which plugs into the main power input port of the motherboard. The PSU itself is just this little card, and it's a DC to DC adapter card basically. This 24 pin connector gives power to the motherboard, and then this 8 pin connector, let me make sure it shows up yet. This 8 pin connector plugs into the motherboard as well to power the power supply of the motherboard. So motherboards for modern power supplies have 8 pin connectors to power the power supply on them. So formerly motherboards would have 4 pin connectors. We had to make sure to get the 8 pin connector for this motherboard and this power supply combination that we purchased using PCPartsPicker.com to select our components. So this has the 8 pin plug-in and it has a 24 pin plug-in. This cord with the red and black thicker cable will go to our 12 volt input to feed this adapter PSU. It's a pretty small PSU. It's like literally a tiny little thing, and it puts out 300 watts, which is impressive. Our PC parts picker build said that we needed 130 watts to power this build because it has no graphics card, and so that's pretty good. So this is plenty of wattage, and then it's got a couple three SATA cables. No, it has two SATA cables in case if we wanted to use the more traditional SSD that comes in a little brick. We could put two more on, so that could be a couple 2 terabyte SSDs right there, or we could power a CD-ROM drive, which we'll need to install Windows most likely, using this kind of old style plug. I believe it's called the ATX plug or something. I'm not sure. No. It's called a. I don't know the name of it, but this plugs into like CD-ROMs or the old school hard drives. It's got the circular metal pins that plug in. Yeah, it's the old school kind, and then this is the smaller kind. But this one will go to a CD-ROM, like the old school CD-ROM plug-in style, and then this one can go. This SATA one could go to SSD. We could get a 2 terabyte SSD for this, or we could get a HDD. But SSD is faster, and we're probably going to want to go with everything as fast as possible, so we'll probably go SSD for the robot. And then this could go to yet another SSD, so that could be a multiple terabyte SSD, and then this could be for a CD-ROM drive. The CD-ROM drive will uninstall after we've installed whatever CDs that we wanted to install. Most likely that's just going to be maybe just the operating system itself from CD. Windows 7 is what I want to go with because I'm just used to that. So I'm probably going to need a CD-ROM drive in order to install Windows 7. I had to do that on my current gaming PC build that I'm on right now. So for whatever reason you can't install from USB Windows 7 onto modern UEFI BIOS systems. You have to install it. I think it's called UEFI. The old school BIOS systems you could select, or I think you could configure it to boot from USB, but for whatever reason you can't boot off USB with the particular version of Windows 7 I have. I don't fully understand it, but you had to use CD-ROM. I spent like 5 hours figuring that out in order to install Windows 7 on a Generation 10 processor motherboard. So yeah, so that thing will be useful for this. And this whole thing needs pretty much straight 12 volts. It could be plus or minus 15% on voltage. So that means it could be, I believe it was like 10.2 volts up to 12.6 volts. And because I'm using lithium ion batteries, which have 3 volts per cell at empty and 4.2 volts per cell at full, 3.6 volts per cell at nominal charge. If you do the math, if you were to use 3 in series, you'd get 9 volts to 12.6 volts, I believe it was. Or it might have been, 4.2, yeah, 9 to 12.6 volts it can produce. But this requires, what do we say, 12.6 and then down to 10.2 or something like that. So basically, what I found out is that with 3 batteries, once they're below about 40% charge, this board would stop working because it doesn't have the minimum 10.2 volts, since the batteries would be down below that when added up in series. So that's unacceptable to me that our battery bank can be at 40% charge still, which is still like halfway full batteries, and suddenly the PC would just shut off. So the robot would go dead because his batteries are at halfway full. No, we want the batteries to be able to discharge all the way down to nothing before the robot's brains would shut off. So, in order to solve that, I decided I would provide an adapter that produces 12 volts all the time, and then just way overshoot the voltage on the batteries and then convert it down with a 12 volt regulator. So for that I bought this $18 golf cart DC buck converter 20 amp 4.8 or 48 volt 36 volt voltage reducer regulator 12 volt. Okay, so basically this will take anywhere from 30 and up to 60 volts as the input voltage range, and then it will lower that voltage down to 12 volts. And because a lot of people buy golf carts, this had 2,000 sales on it. It was only $18 in free shipping, which is fantastic. And it's pretty small, and it's got its own built-in heatsink, and it's 95% efficiency. I believe the PSU was about 95% as well, so it's not going to produce that much heat since it's high efficiency. And at 20 amps, this is going to output approximately 240 watts, which is less than our 300 watt PSU. So that's going to be a bottleneck for us. We'd maybe need to buy 2 of these to make sure the PSU is never underpowered. But in theory, we're not going to actually need the full 300 watts of the PSU anyways, because the PC build I made says it's going to run on approximately 130 volts or 130 watts only. So maybe it'll have a spike of 160 watts, and since this produces 240 watts, it's going to be plenty in theory. So we'll probably be fine with this. And so this is going to take between 30 to 60 volts. And so I'm going to use 10 in series lithium ion batteries. So let's just say at 3.6 volts per cell as the nominal charge. If you multiply that by 10, that's 36 volts that it will be putting out. And even if it were at 0 charge, that'd be 3 volts per cell. Times 10, that's 30 volts, which is the minimum that this particular regulator requires, 30 volts. So even when the batteries are just about empty, this is still going to put out 12 volts. And so that's perfect. And so 10 series is how we're going to have to run our batteries. 10 in series lithium ion batteries. And we're using specifically Sony VTC6 lithium batteries. And that's the type of batteries I believe you use for vape, or a lot of people use them for vapes. They're very high amp output capable batteries with very high capacity. They're like $4 per cell, I think, or it might have even been $6 per cell. They were pretty expensive. I think it was like $1,200 to buy like a huge block of them, like this big. And my dad paid for it because I told him I was buying batteries for an e-bike, but I'm going to use it for the robot since we don't really go biking as much as a family. But I can always take them out of the robot and put them into the e-bike, possibly in the future, although I doubt I would want to do that. Maybe I could, I don't know. So yeah, I guess I'm repurposing something that he bought for something else, and that's not necessarily cool, but we don't really bike together as a family that much at all. I mean, we've done it once, so I'm not too worried about it. I'm just going to use it for the robot. So anyways, that's how we're going to do the power feed. So we're basically having a gaming PC running off Sony VTC6 batteries, 10 in series, using a reducer regulator 12 volts from a golf cart, and using this power supply And I specifically chose the Intel Core i5 10400, not the 10400F, which has no onboard graphics, and not the 10400K, which has overclockable hard drive. We don't want to overclock because we don't want to risk like it producing too much heat or whatever. I don't feel comfortable overclocking. I think it's the processor lasts longer if you don't do that, and I just don't want to get into that. I mean, I've never actually overclocked myself, but it was something that like only enthusiasts for overclocking did in the past. Now it's becoming almost everybody does it. So that's a change. It's very popular now. Overclocking is like standardized now. And so I think the processor makers may actually be factoring that in and making, even with overclocking, the processor doesn't just last a shorter amount of time. Maybe it has the full lifetime. I don't know. So things are changing in that realm where overclocking is almost expected, whereas before it was almost like a hack. So I might start overclocking my processors going forward at some point when it becomes just the norm. But for now, I'm not doing that, and it's a little cheaper if you don't get the K version, which allows for overclocking. So this is locked. It doesn't allow for overclocking. But the real cool thing is that this does have integrated graphics on it that's probably really good because it's 10th generation. You can actually run games at high frame rates, like pretty much modern games for the most part. I mean, not probably highest settings, the very latest games, but like fairly late games. You can run on this onboard. It's got a built-in GPU into the processor. Now, obviously, a dedicated GPU is usually preferable for gaming, but my thoughts are for a robot, it's not needing to run high-end graphics. All it's going to be doing is taking in the various webcams from his eyes data and then processing the visuals on that, processing the pixels, and that's probably going to be processor intensive. I don't know how much of the video card that would actually use, probably very little. Maybe just resizing. It might use a video card function to resize the image. I don't know that my computer vision algorithms that I've developed so far and the ones that I'm going to be developing will actually be tapping into the video card functionality very much to do that processing. Video cards generally are used to produce graphics for you to look at, not for reverse engineering pixel data into object recognition. So for that reason, I don't think the video card will actually benefit us very much at all because we're not even going to be having a monitor. The robot is not even going to have a display. So the video card is fairly not important. So whatever's built into a modern processor that has a built-in GPU should be fine for our application. So that saved us a lot of money not having to buy a video card. Well, unless we bought like some really cheap one anyways. So yeah, that's going to save a lot of space though. So that's another really great advantage. We're going to have a very compact little system here. For a gaming PC, that's going to be very compact and still very powerful. I opted out of using Raspberry Pi or whatever other options you can get because compared to a modern gaming PC, those are way lower in RAM quantity, RAM speed, processing speed, number of cores. To buy a modern gaming PC is for the dollar so much faster, so much better than buying some type of like um, specialized like robotics wannabe PC thing. Like um, like Arduino, obviously, we're going to be using Arduinos for like low level stuff, but for the main brains, we need a very fast RAM, a lot of it. We're using 32 gigabytes. We need a multi core. This is a 12 thread processor. We need a lot of cores, a lot of threads, so it can multitask a lot of things at once. And so, um, it's just not good, I don't think, to use like a Beagle Bone Black or Raspberry Pi or whatever type of like thing that's used for toy robots. This is not a toy robot. This needs to have extremely fast processing to be able to do hopefully as much as possible. We might be looking at, let's think about this: voice recognition, sound recognition, um, actual speech production. Like it needs to be able to convert what it wants to say into words and sounds, and then emit those sounds in order to be able to speak. So voice generation. It needs to have computer vision with object recognition. It needs to have advanced motion planning, general planning, reasoning, learning. It's going to have a lot of things going on all at once. Um, Fortunately, this motherboard actually has quite a few USBs. We're probably not going to need a mouse and keyboard after everything's installed as far as operating system and whatever programs. So we'll be interfacing with this PC through Wi-Fi, which it has built-in Wi-Fi antennas, which is great. So we'll be able to communicate with it through Wi-Fi and through Bluetooth. It has Bluetooth connectivity. And through that, we can remote desktop. So we can do whatever we want. We'll be able to see what it sees, so to speak, by logging in remotely through. We'll probably use Google Chrome Remote Desktop. That's what I use. In fact, I'll be able to log into it on my phone even and see what's on its screen, so to speak, even though it won't have a monitor screen. And we can do remote updates automatically this way, and backups to the cloud and everything else. So it's very important for it to have Wi-Fi, very important for it to have USB, so that through its USB interface, we can connect the mainbrain's motherboard to an Arduino or multiple Arduinos, depending on how many USBs we have access to. And then once we connect it to one Arduino, then that Arduino can bitbang communicate with all the other Arduinos in a whole network of them, and we can have Arduinos that communicate with the various motor controllers and do low-level motion planning, low-level muscle motions, low-level sensor input, like all the various different types of sensors, whether it's like collision detection sensors, pressure sensors on the fingertips and stuff, which would be called strain gauges, and amperage / current detection sensors for detecting if or how much force is being placed onto each of the different motors in order to determine any resistance to movement. If there's a current spike, then you know that the hand probably bumped into something. So that's the collision detection type thing. So yeah, there's going to be a ton of low-level stuff that our series of Arduinos will be doing, and they all need to communicate with one another in order to feed all of the information of everything going on with the body of the robot back to the main brain's computer, which then can make motion planning adjustments based upon that information. So for example, if he's throwing something and the motor sensors or the sensors detect that the hand bumped into something, then he would need to plan for, okay, what do I do now? I can't complete the throwing motion, I just hit something. So then maybe he'd look to see what he hit or whatever. So the main brains and motion planning all needs to be interactive with environmental factors and with this information that's coming in real time. And so there is a need for the main brain's motherboard computer to be able to interface with these smaller microprocessors. And so USB is very important for that. Also, he'll need USB, at least one or two USBs, to interface the main brains to the webcam eyes. I'm going to actually create artificial eyeballs that have motors that can turn them, and there's going to be little webcams inside them, and he'll be able to look around with actual eyes. And those little webcams will need to USB connect to the main brain's computer for processing that visual data. We're using two webcams that move together spaced apart, which will produce two sets of images, which then in software can be compared to gain depth perception cues in order to have stereoscopic vision capabilities, which will then enable the robot to kind of determine how far away things are in his environment. And that will help the computer vision algorithms to make sense of its environment without the need for LiDAR. Although we might eventually install LiDAR at some point, possibly. But computer vision with stereoscopic vision should be enough, I believe, to make out its environment. And be able to determine the depth and distance of all the different things in the environment and identify what they are. That's the goal. So he'll need USB, like maybe two USB plugs for the two webcams. And then the webcams also have speakers built in, I believe. I mean, not speakers, recording devices, so microphones built into them that collect ambient sound information. So maybe we won't need any more microphones besides what already comes with the webcams. And the robot would be able to hear through the same webcams he uses for his eyes. Although a webcam that has a built-in microphone would probably be too big to fit into an eye. So we would have to separate the webcam portion from the microphone portion and possibly just put the microphone behind his eye with the webcam extended through wires to the surface of the eye. And this way, as the eyes turn, the microphones don't impede that movement. There will have to be some modification of a stock webcam in order to use it for this application. And I'll probably just use a Logitech webcam like the ones I use for the stream right now for this. And then, so that covers hearing and sight. And then we need sound. We'll need speakers. This type of motherboard has actual speaker out plug, which is what's it called? A jack style, barrel jack style. So we might actually just use actual speakers, PC speakers, which we can put in the robot somewhere. I'm not sure. I haven't planned out where to put them. And as I think about the robot, I can actually pull up the model of the robot. We can see all the space, like almost all the space is already taken up by tons of stuff, but we never put anything in the actual skull yet. So we might put speakers inside the skull and then just put holes in the forehead, all over the forehead, which is going to be behind skin, but those holes will let out plenty of sound. And so the speakers might actually be inside the skull, so the sound will come out of the forehead, which will be kind of natural-ish. Maybe even the sound could come out the nose holes too. You might be able to pipe the sound right out the nose. So the closer to the mouth the sound comes out, the more natural it's going to seem if you're like standing right in front of it. If you're like standing in front of a robot and you hear the sound coming out of its toes, you'd be like, why does it sound like something's talking to me from the ground? So you do want the sound to be coming out of the head of the robot in order for it to seem not really weird, because you'd like looked out like the sound doesn't seem to be coming from the face of this robot. So it needs to come out somewhere in the face area. Can it come out the mouth? Maybe. But where would we put the speakers? Like, maybe we could put them... No, I don't know if there's enough room right here to put speakers, because there's going to be all the muscles. You can see tons of muscle connection points happen in the neck region, so I don't think speakers can go there. The only place we have for speakers left, which we didn't fill with stuff, is inside the skull itself. So we'll probably put the speakers in the skull. So the barrel jack plugs of the motherboard will have the speaker out port, so that will enable us to have the speakers. So that takes care of that. So that's him being able to speak and hear and see and touch that we've covered. What else would he need USB for, or what other type of in-out interfaces would we need? Uh, I don't know. I think that about covers it. So this motherboard does have enough in-out ports on it to cover all of our needs, I believe. And we could always take a USB and go into a USB expander adapter. It's called like a powered USB expander adapter port or something. I use it for my computer, so we could always do that. Although I don't know if that slows down USB speeds by a lot, which could matter, especially if you're dealing with webcams and real-time information needs. We might not be able to afford that for this super high-speed stuff. We're going to need the webcam information streaming into the robot as fast as possible so he can process that information and know what's going on in his environment and have quicker reaction times. Like if you just threw a tennis ball at his head, you'd want a robot to be able to catch that before it hits him in the head, right? So you're going to need super high speed vision information getting to the brains of the robot and being processed quickly in order for him to be able to react with like superhuman reaction time to things, which is a goal. Alright, so I'll go ahead and read the chat. I think I pretty much am done here with letting you guys know what specifically I bought and why. And it's a pretty exciting development because I'm kind of excited to get some batteries put in and get the PC running. And then once I have that PC, I can start actually coding. And then from that, I can then have commands being sent out to the various microcontrollers and then getting that feedback loop where he's actually able to send commands and then get responses back to send commands to the microcontrollers and then get responses back letting him know, hey, like the arm's running into something, or hey, we don't have an arm, it got cut off, or whatever. Okay, so let me read chat. Could you do 2 SSDs in RAID? I don't know if this particular motherboard allows for 2 SSDs in the M2 format, but because it has SATA connector ports on it, we could use a SATA connector cable to run from the motherboard to another SSD or multiple SSDs to go along with, but those would be like the normal brick kind that weigh like a few pounds or like 2 pounds instead of like the M.2 style that just plugs directly into the motherboard on a card, which is something that blew my mind. I just found out about that today and I bought it. It's a pretty cool high-speed connection for modern motherboards. I'm behind on knowing about that. I just found out today. Okay, so yeah, we can definitely do more than 1 SSDs, but we definitely won't need that many SSDs at the start, but we're going to need a lot more as the robot begins to learn. He's going to create knowledge trees. So like, he'll learn, I'll say, this is Hannah, my wife, and he'll like take a snapshot of what she looks like. He'll pull certain features of her. Okay, she's Latina, she has black hair, she has this shape of face, and it's Master's wife. Okay, so then he'll put like Master's relationships. He'll put wife, and then her name, and then he'll create a file on her, and that file will have a list of features about her, things that she has taught him, and things about her that he has observed, and things that she likes and things she doesn't like, and things she has told him in the past. And all this information will be about her, and that will be stored on the hard drive. And so that way he'll be able to create trees of knowledge based upon relationships to certain people and who knows who and how did he meet so and so, and dates where he added her to his file, and maybe keep logs of when he's talked to her and what she's said and when he's last seen her in order to be able to recall information and be able to form some type of understanding of the world around him. He'll create logs and files on everything that he learns and why he learns it and how it relates to everything else. And that's getting now into advanced AI and learning algorithms, which I have planned out. I told you guys, I believe I can create some really amazing AI, and it's super exciting stuff. Okay, so we'll definitely need to have a lot of onboard storage over time. But then, like, somebody that he doesn't see very often, like my cousin in Texas, he might have a file on him, but it could be very bare bones, and then he'll have like more extensive information about his interactions with that particular cousin on the cloud, and then he might delete it from his onboard memory. If he hasn't seen my cousin who lives in Texas for like 5 years, he'll move that information, the files about him, to the cloud in order to clear up more short-term memory on his onboard. So he'll have a combination of cloud and onboard memory and knowledge databases and knowledge trees, and this way he won't run out of onboard storage for stuff he needs to look up quickly. So it'll be based on relevance and needs on a daily basis. He'll have stuff that he'll need all the time, so that if he ever goes offline, he'll be able to function and interact with his immediate environment very well. Although he won't know that cousin in Texas. If that guy happened to visit him, he'd be like, I don't know you, but no offense, I'm not connected to the cloud right now, and I haven't seen you in at minimum 5 years because you're no longer stored on my onboard memory. Once I get access to the cloud and connect to the internet again, I'll be able to pull down all the information about you and then remember you again. So that would be kind of how that conversation might go if that came up. if that cousin said, hey, why don't you remember me? Alright, Adam needs 400 HP. You're talking about health points? How much will the robot be able to lift above her head? It's going to be a he. And overhead lift, I want it to be pretty close to my strength, so in theory I think I actually have designed a robot that will be close to my strength, although it's hard to say if I'll actually achieve that. But I believe my design does allow for that. Literally, it will be about as strong as me. Now, I'm not sure about the deltoids. The legs, I think, are definitely as strong as mine. But I'm not positive on that either. I'd have to run a lot more calculations. But supposing it's approximately my strength, well, then it'd be like 50 pounds each hand overhead lift, 50-pound dumbbells per hand. For like, what's this called? Military press, I think. Why not do the compute on a server and control the robots with Wi-Fi? Then you just need a receiver on the robot. Because if it ever gets offline, it's going to be completely retarded, brain dead, won't be able to do anything. So that's a really bad solution for a lot of stuff, but maybe some type of like really creative computations that are like really out there and take a long time to figure out. He could offshore, we'll call it, to the cloud, which can then be done on a server, as you said. And that's a smart idea for stuff like that. But if it's like robots walking through the house and the Wi-Fi goes out and he just trips and falls and breaks himself and falls into somebody, that's not good. So he needs to have the majority of his computation happen on board. And it has to be non-Wi-Fi dependent. You want as minimal Wi-Fi dependency as possible so that the robot can function well without the need for Wi-Fi. Can you imagine how bad it would be if you weren't able to think without Wi-Fi? Like, if you have a power outage, you would literally, as a person, like, just become a zombie? That's not good. Like, we love internet in 2021, but we don't love internet so much that if the internet goes out, we want to cease to exist. That's what would happen under that type of design. That's not good. Do I reach out? Yeah, but I was recording everything in like one thought flow before I did that, reading chat, because that interrupts my thought flow, and I wanted to have like a short video that just kind of goes through everything that I bought and why for purchasing the robot's main onboard computer. How did you get so smart? Were you always smart, or did you study a lot? My intelligence is probably slightly above average potential, and then I believe that I always applied myself and was a deep thinker and always asked a lot of questions, so my intelligence started to slowly grow more and more above average, and I could be considered bright. And then a lifetime of studying and learning and using my mind a lot and challenging myself has expanded my mind and made it strong. It's like the mind's like a muscle. If you use it a lot, you get smarter. if you read a lot, you get more vocabulary, for example. So over time, I have gotten smarter. And then as far as me being able to explain a lot of technical things here on the stream, that just came from tons of studying. But the purpose of today's update stream was just to tell you guys the onboard PC that I bought that I'll be able to put onto his internals and that's going to run him. And like I said, I wasn't planning to buy that for years to come because I just figured we'll just use like a crappy computer I already have. But because I decided um, I just wanted to know how big this computer is going to be when push comes to shove. So that's why I bought it, so I can actually put it in there, see how much space we've really got. It's so important to know how much space you've got to work with. And this helps a lot with designing the spacing of everything, but it can only go so far. You actually need to have stuff in hand and actually start putting it together to see if it really fits. And there can be things you didn't factor in, too. So yeah, plus it'll be nice to have a nice fast computer to start out with. And if in 5 or 10 years when we really start getting the AI done and getting the robot really working, if computers are 10 times faster and you would say, well, I wasted the $600-700 I spent today, it wouldn't really be a waste to me because it still helped me to determine what size, and it helped me to set up maybe some basic AI and basic functionality of the robot for now. It's a placeholder. It's an expensive placeholder, but it is what it is. I mean, I want to keep progressing, and I just didn't want to keep putting off having the main brains of the computer of the robot. So, anyways, looks like I answered everything in chat. I'm gonna end it here. I just wanted to give that update. It's exciting to get something done on the robot, anyways. I don't get to work on the robot as much as I'd like because right now I am building a garden, a hydroponics, or kind of, yeah, hydroponics. I'm also doing aquaculture, so I'm raising shrimp, and I want to raise salmon eventually too. So I'm learning how to produce my own food at home, which I think is just really cool as a kind of aspiring prepper. With COVID, you hear a lot of conspiracies about big economic crashes and wars and all kinds of stuff. So it's kind of like nice to just be prepared for whatever. Just nice to have the ability to make at least some of your own food and stuff. Plus, I mean, it's extra healthy and organic and green living if you have like solar and you're off grid and you make your own food. I really think homesteading is pretty cool, but I don't actually live in the countryside, so I'm just doing like an indoor homesteading kind of, you could say, basement homesteading. And I just think it's really interesting. Plus, if you ever actually do successfully create a robot army, you can have the robots do all of your farming. So you'll get free food then, like totally free, because it'll all be passive made by the robots. And if solar power powers the robots, it's literally like free electric and free labor producing free food. So that could make you save a lot of money. Then you're just paying like property taxes if you have your house paid off. You have the robots do everything. So it's just kind of cool ideological stuff, bucket list type stuff that I'm working on. And so that's one thing. And then I'm also remodeling the house, which I chose not to stream it. And I'm fixing up all the cars that I have, a bunch of junk cars in front of my house that I'm trying to fix up. And I'm flipping some, I'm keeping some, but I have 3 cars that I have to fix that are all in various stages of disrepair. So that's been a lot of work, and I do most of that on stream, but some of that off stream. I'm choosing not to stream everything. If it's something boring, I just don't bother streaming it. Because every time I stream, I have to like download the video and edit it, and I spend a lot of time talking to chat, and that can slow me down. So, and plus I lose track of time when I stream. So anyways, that's the update, and have a good day or night, guys. I'm gonna end it here.